What's up, AP Pre-Calculus students? This is your first homework video of the year. Uh, this is the day before school starting. You can see it's the 15th. This is Tuesday. Let me just preface these videos with a couple of words of advice. You should not be doing the homework while watching this video for the first time. Like, you should not be saying, oh, I need to do my homework. Let's start the video. You need to try the homework yourself. And this video should be like a key, a very long key that you're like skimming through. Okay. You're seeing if you're getting the right answers. And if you're not, or if there's a problem that you don't know how to do, boom, that's where the video is going to help you the most. The key, I think, in mathematics education is you got to struggle. You have to like work through mistakes. The quicker you guys make mistakes and realize the mistakes and fix those mistakes and redo problems that you're getting wrong so that you can't get them wrong again, like the better you're going to become at mathematics, okay? You really have to struggle to learn mathematics. Now, of course, there's some of you out there that's like, this is a breeze and like, I don't have to worry about anything, but not it wasn't like that for me. I was like a bad math high school student, became a great math college student when I just decided to struggle. I decided to really work hard. So, anyways, I have not done any math over the summer, okay, at all. I have not even looked at these problems. We created these problems, but I haven't really looked at them and what they're in store. So, like, I'm going to be making mistakes in this video and I'm going to be rusty just like you are. And that's okay. We're allowed to be rusty. We're allowed to have bad penmanship. We're allowed to do all those things. But we got to warm ourselves up and we got to be like getting better, ready for our first quiz on Friday. First quiz is on Friday. Off of these questions, you got to be able to know every single type of question. Don't just assume, oh, that hard question, you're not going to see that. Usually the hard questions are going to be on the quiz. So away we go. We're solving equations, so like algebra 1, but maybe it's tougher because we got some fractions, maybe we got some stuff that we forgot about. Fractions, it's all about common denominators. You can see we have halves, we have fourths, we have a whole number. I feel like common denominator, it's like make them all like terms. Fourths are going to be easy to use. So I'm going to multiply this by a version of 1. It doesn't change what we have. It just makes it look different. This is 6x over 4. I'm going to turn this to 4 over 1 and turn this into 16 fourths. I like to change subtraction and to add the opposite. That way I don't make any mistakes with signs and subtracting negatives and stuff like that. I'm going to change the 5 halves into 10 fourths. I'm going to keep the 7x over 4 or 7x quarters. Okay, now I'm just going to kind of combine my x's, combine my numbers, get them all onto one side for some, other side for the others, and isolate the x. So probably the best thing to do is to remove the 6x over 4s from this side so that they remain on this side. And then go ahead and get this number onto that side, remove it from the right side so it remains on the left side. And it is okay to always think about adding. That way you don't make mistakes here, like negative 16 fourths plus negative 10 fourths is going to be negative 26 fourths. This is 1x over fourth. Remember, when you're adding and subtracting fractions, you don't change the denominator. You have an amount of fourths. This really works out nicely because I'm just going to multiply both sides by 4, and I have my answer. X is negative 26. If you'd like to, you can go back and check. If you plugged in negative 26 into the beginning, or you get the same thing. It's probably too much work to check. I like to say, like, get it right the first time, and you're going to be fine. Don't worry about checking if you know you're not making mistakes as you do in the problem. All right, same thing here. We got like 12ths, thirds, sixths. Why don't we just make everything 12ths? Turn this into 4x over 12. Turn this into 10 twelfths. Keep that as 7 twelfths. And again, like, I could be making mistakes here. It's totally human after a summer of not thinking about math, and I didn't think about math at all over the summer. I was just mostly playing with my kids. We were at the beach in LA, we were at the beach in Charleston. We went up to Maine where we were playing in Booth Bay Harbor. So, like, playtime, not math time. That's the life of the teacher. You get to have fun over the summers, just like you kids, if you're a teacher. So, yeah, I'm a little bit concerned, and like you should be, whenever you get like a crazy looking answer that maybe doesn't simplify nicely, you should be kind of in this class and other math classes thinking, did I make a mistake? 17 fourths. First of all, we're going to leave our answers like that. We're not going to turn it into like an improper fraction or anything. This is not 4 and a fourth. I don't like that. That's used for like cooking. We like to keep this fraction as an amount of fourths. Okay. Can quickly double check 10 twelfths, 4 twelfths, 7 twelfths. Add. These are negative. Add 10 twelfths. To get rid of the negative 10 twelfths, 17 twelfths, 4x twelfths. Okay, yeah, I mean, I think I did it right, but if you guys catch me in an error, good. Like, that's good. It means you're doing the work and you're checking with me. You're not just copying what I put down. Don't just copy what I put down. You gotta struggle. All right, I'm changing subtraction into add the opposite. I'm going to remember about distribution. What I like to call distribution is like the amount of bags that we have. Like, what happens if you empty the bags? Okay, like think about the stuff inside the parentheses as like a bag of stuff. I have in this bag 3x and a minus 1. Okay, well, I have 2 of those bags. Empty the bags, what do you have? You have 6x's and a minus 2, or 6x's and 2 negatives. Also, outside of this bag is another negative 6. Combine it all, and I have 8 negatives over here on the left side. I have 4 bags of x minus 2. What do I have total? 4 x's and 8 negatives. It's just distribution, but maybe just like thinking about it differently so things make sense. I like to try to make math make sense. You'll experience that this year. Understandings of math. This is a fun question, and it's good to make sure we try this question and see what happens with this question, because after moving the x's to the left side and getting rid of this negative 8, while I realize that both negative 8's go away, I get 2x equals 0. Well, some people might think, oh, this must mean no solution, but that's not true. X could equal 0. If x equals 0, then 2 times 0 is 0. So that's a solution that works out. This is an easy thing to check. If you went back into the original equation, you get 2 times negative 1 minus 6. 2 times negative 1 is negative 2, minus 6 is negative 8. Then 4 times negative 2 is negative 8. That works. X equals 0 works. Here, boom, 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 boom. Don't make any mistakes with distribution. I have, after emptying the 3 bags of 2x minus 4, I have 6 x's and I have minus 12. 5 bags of x minus 3 give me a total of 5 x's and 15 negatives. 3 negatives, 5 of those, 15 negatives. Okay, emptied the bags. Going to get rid of the 5 x's. You can subtract, you can add the opposite. I know you pre-calculus students, a lot of you have like your own ways that you like to do things, and you don't like to do things any differently. That's okay. You don't have to change all of the subtraction symbols and to add the opposite. You don't have to listen to your teacher. But through years and years of experience, I know students that make mistakes. They make mistakes because they don't know how to handle negatives. Like in the next questions, you'll see, like, if you don't know how to handle this negative, you're going to make mistakes, and I'll try to help you prevent those. Okay, we move into function notation, which we need to be comfortable with in this class. All you have to understand is that, a function is just a program. It's like this program uses x's. Okay, this program using x's this is what you would do with the program. You'd take 5, you'd subtract 4 amounts of 6 minus whatever you've used, okay? If I ask you to find f of 0, the question is like, if your program uses 0 instead of x, what would you get? That's it, okay? Like, what do you get if your program uses that value? I don't like to say, oh, just plug in. I don't like to say, just do this. I'm not going to say it. This is also like me reminding myself of how I teach. Like, don't say, just do this. I don't like to do that. Instead, say, okay, if I'm using 0, what is my output? What do I get from my program? I get 5 plus negative 24, which is negative 19. That is what my program gives me. Okay, now they say, when does your program give you 0? For which x? So for which x does your program give you a 0 output? This is when we're saying, when does your program give you a 0 output? Okay. Now we are finding x. We are not plugging in something for x. We're not using something for x. We're finding what x, when used, outputs 0. Okay, so this is a question that we kind of saw similar before, like solving this equation. I'm going to change things to add the opposite so I don't make a mistake. This is a common mistake made. Heads up. Make sure you distribute the negative 4. So I get 5 plus negative 24. I got plus positive 4x, and I get 0. Negative 24 plus 5 is negative 19. I add 19. I divide by 4. I'm running out of space, so which is why I'm not showing the steps, but that's fine if you don't show the steps and you just know what the step is that you're doing, and you get 19/4. Now, what's very important is that if you're talking about how functions can be graphed so you can see based on an input what your output is, this is called your y-intercept. Your y-intercept is when you have an input of 0. When your x value is 0, you will cross the y-axis here at negative 19. This is called an x-intercept. An x-intercept is like, what input value will you get an output value of 0? Okay, and you can graph all of the values, inputs and outputs, so you can see for this input, I get that output. That's what a graph is. Okay, it's just like the visualization of all of your inputs that map to an output. F of negative 3, F using negative 3 in the program. It's important to not change anything. I'm subtracting negative 3. It's like adding a positive 3. Subtraction is the same as add the opposite. I would probably recommend you change all subtraction into add the opposite. If you made that mistake and you're checking the key, well, maybe change your strategy so that you don't make that mistake again. So I have negative 24, I have negative 12, and now I'm going to combine all my numbers. Negative 36 plus 5, negative 31. Yo, these videos are going to be like super long too. Like, it's a way for me to be ready for the lesson and stuff like that. It's going to be shorter if you just do the homework. Okay, if you just do the homework and use this as a key, short. You could be done like that. If you just watch the entire video, it might be a lot longer watching my video than actually doing the homework. Just letting you know that, especially the way things are starting. All right, so now what is the x value that will produce an output of negative 3? Functions are inputs and outputs. So I got 5 minus 4 times 6 minus x equals negative 3. Now I got to find the value that will produce this output. Plus a negative, distribute. Empty out the negative 4 bags of this, and I got negative 24. A negative 4 times a negative x is a positive 4x. Negative times a negative is a positive. I get negative 3. Might as well combine. Same side combine. Negative 19. Add 19. Will we get a nice solution? Yes. Sweet. All right. Should be straightforward. Maybe some of us are a little bit scared about function notation. Don't be scared. Just do it. Get used to it. We will make sure you are prepared for everything, and you can't always assume it's gonna, like, we're gonna show you the same type of problem 5 different ways. You got to be ready for all the different ways. We don't like to teach, and we don't like to say just do this. Okay, for a certain unit or a certain lesson, it's never going to be just do this. It's like really understand what's going on mathematically. Solving equation, getting x's by itself versus maybe might look the same thing, like you're solving equations, but the question is asked differently. So that's what, like, what's x? What is the hidden value of x? So isolate x, that's 27, by undoing what is being done to x. Probably should explain this. This is good stuff for me to remember. Undo what's being done to x. X is being squared, then multiplied by 3, then add 4. Undoing that, get rid of the 4 first, get rid of the 3 second, get rid of the square last. So I got rid of the 4 first, got rid of the 3 second, get rid of the square by square rooting. Square root of 9 is 3, but when we solve an equation, a squared value equaling 9, both positive 3 times positive 3 is 9, and negative 3 times negative 3 is 9. This is stuff that we worked on in Algebra 1 and Algebra 2. We are reviewing it. It's important for pre-calculus as well. Pre-calculus, first semester. Review of Algebra 2, just at an AP level. Second semester, new stuff. All right, same deal. Undoing what is being done to the x in opposite order. 36. Really? We're going to get the same answer? Nine times 4, 36. Plus 5, 41. All right. We're going to try to keep most of the things normal, but there is going to be some rationalizing. So we'll review that in a second. Okay, what is being done to x here? All right. First, x is being subtracted by 3. Then we're squaring it. Then we're subtracting 2. To undo that, okay, this is important. What should we do first? Well, whatever's done last, let's get rid of that first. So the minus 2 is last. So I'm going to get rid of the 2. Then I need to get rid of the square. Then I'm going to get rid of the minus 3. Okay, we're reverse order of operations. So undo what is being done. We start out with that. Okay, we square root. Now remember, positive and negative values squared give us positive values. So that means when we square root to solve an equation, we have both a positive and a negative possibility. So if I get negative 4 here, squared, positive 16. Positive 4 squared, positive 16. And then I got to add 3. Now, what I like to do is maybe put it right here in front, especially for the next lesson. It's nice to have it like this because there's some complex answers or answers with radicals where we can't simplify further than this. But for this one, I can. I can do 3 minus 4, which is negative 1, and 3 plus 4, which is 7. And we'd expect you to be able to get those two numbers. All right, same deal here. We don't have any rationalizing yet. I assume we're going to have it, so we're ready for it. Square root both sides to get rid of the square. Add the 2. 2 minus 5, negative 3, 2 plus 5, 7. Whether you have your answers like that or that, it's no big deal. Just understand that this is not a point. This is not an input of -3, output 7. These are two x values. X could be -3, x could be 7. If anything, I think we don't hit pops up, we'll make sure we do a couple practice problems before our quiz on Friday. So if we don't see any rationalizing, like we're going to practice rationalizing because I think we have it in the lesson. It just might not be in the homework. All right. Here we go. We talked about x-intercepts, y-intercepts, x-intercepts, where we cross the x-axis. Where do we cross the x-axis? When y is 0, when our output is 0. So I will output this to 0. I'm going to add 4. I'm going to square root. I get x plus 3 equals a positive or a -2. I will then subtract 3, -3, plus or minus 2. You can have plus or minus 2 minus 3. That's fine. -3 plus 2 is -1. -3 minus 2 is -5. -5 or -1. These are two x values. You can have it as x equals and x equals or separate like that. Let's make sure that works. -5 plus 3 is -2. Squared is 4. Minus 4 is 0. -1 minus -1 plus 3 is positive 2. Squared is 4. 4 minus 4 is 0. Y-intercept is when x is 0. All these points on the y-axis are when x is 0. You can always draw a graph. You don't have to have it memorized. It's like, oh, these points are when my input is 0. What is my output? Here, what is my input? What is my x when my output is 0? So g of 0 is what we're finding. That is, what is my function when I use 0 instead of x? 0 plus 3 is 3. 3 squared is 9. 9 minus 4 is 4. Could we have a y coordinate of -10? Well, here's the problem. When I add 4, I get -6. When I square root, there's no real number when multiplied by itself that gives us a negative. Okay? So on the real graph, on the graph that you can see on the x and y axis, no. There are solutions to this equation that are imaginary. We are going to review imaginary solutions on day 3. But for right now, no, you can't solve because there is no real number that you get when you square root a negative. Like a positive times a positive value squared is a positive, a negative value squared is a positive. So there's no real solution because x plus 3 squared cannot equal -6. Heads up. If part of your answer involved the square root of 12 or something like that, you would need to rationalize this. Now, we practiced rationalizing last year. You find the largest perfect square that goes into our number. Here are my perfect squares: 4, 9, 16, 25, 36. See, 4 goes into 12. So root 12 is the same as root 4 times 3, which actually there's a exponent property saying that you can split this off into be root 4 times root 3. And what we want you to do is be prepared to rationalize. If you don't remember rationalizing, we're going to practice it on Friday before our quiz in case there's a rationalizing question on the quiz. If there isn't, then we're not going to practice it, but it is something you need to know in this class. All right, we're back to solving. We're just isolating x. What is x by itself? Same deal. Like We could either undo what's being done. We try to simplify. Like right now, we have like 3 bags of this. Well, why don't we empty the bags? Or you could say the last thing being done to x is multiplying by 3. You could get rid of the 3 first if you want to. I'll show you both. It's important in this class to know like there might be different approaches to the same equation. Let's go ahead and empty the bags. Empty the bags means distribute. So if I distribute, I get 7 plus 3x cubed over 9. 3x cubed over 9 is the same as x cubed over 3. Like I can divide the top and bottom by 3. It's not changing what we have. It's just making it look different. So this is x cubed over 3. We can then subtract 7. I get negative 5. Multiply by 3 to get rid of the divided by 3. I get x cubed equals negative 15. And then I'm going to go ahead and get x by itself. Now, one really quick thing. Why do we square root? You got to remember the exponent property of a power to a power. If I have x squared 3 times, that's 3x squareds. That's x to the 6th. Okay. What did we do with these two numbers? We multiplied. Why do we square root? Well, a square root is like the same as a 1/2 power. Why do we square root? Why does that get rid of the square? Because it's like using this product property. X squared to the 1/2, 2 times 1/2 is 1. We just now have x to the first. If I have a cube, I can get rid of a cube with a 1/3 power. It's the same as a cubed root. We're not going to simplify it past that unless it was like a perfect cube. Some numbers that are perfect cubes are like 8, 27, 64. Tougher to work with that, but I'm just going to leave it like that. Let's say instead of distributing, I decided to just undo the 3. Dividing by 3 to start would lead me to this. That's fine. I could turn this all into ninths, but don't have to. I'm going to subtract the 7/3, and I get negative 5/3. I'm going to multiply by 9. When I multiply by 9, I can divide the top and bottom by 3, and it becomes negative 5 times 3 over 1. So that is negative 15. And then I cube root, finish things off with a 1/3 power. And it's okay to leave it as negative 15 to the 1/3. This is something that can be done. A negative value times itself 3 times gets a negative value. So you can cube root a negative, but like squaring and square roots, you can't do that. Okay? I'm talking really fast. If you're picking up on this, great. If not, you'll just review this stuff. Another rule, negative exponents. Easiest way for me to show you this, and this is me like preparing to teach you this, is using numbers like 3 squared, 3 cubed, 3 squared, 3 to the first. How about 3 to the 0 actually? So we know 3 cubed is 27. What's 3 squared? It's 9. How do we get from 27 to 9? We divide by 3. 3 squared is 9. How do we get to 3 to the first, which is just 3? We divide by 3. Well, if we kept dividing by 3, what would happen? Well, divide by 3. 3 to the 0 is 1. Divide by 3. 1 divided by 3 is 1/3. If I kept dividing by 3, I'd get 1/9. What do we find? Negative powers are the same as positive powers, just in a reciprocal. Like x to the negative first is 1 over x. X to the negative second is 1 over x squared. This is how I can remember it. If you just remember negative powers are the same as positive powers, just flipped, you're good. How can we solve this? We can multiply both sides by x squared. In the future, I like to kind of like flip both sides, but whatever. Divide by 18. 2 over 18, divide the top and bottom by 2 is like the same as 1 over 9. So x squared is the same as 1 over 9. Square root. When you square root to solve an equation, you need a plus or minus. Square root 1/9. Square root the top, square root the bottom. You could do this like 2/3 squared is the same as 2/3 times 2/3, which is 2 times 2 over 3 times 3, which means you can just square the top and square the bottom. This will work with any power. A square root is just a 1/2 power, so it is just a power, which means you can square root the top, you can square root the bottom separately. Okay, let's keep going. X is being squared, then we're dividing by 5, then we're subtracting 2. So let's get rid of the 2 first. Don't be afraid of x being on one side or the other. Let's get rid of the 5 next. And here we go. We get to rationalize. Finally. Okay, good. All right. Square root, or it's a 1/2 power. We need a plus or minus. Here we go. Root 50. (25) goes into 50. Root 25 times 2 is the same as root 50. But root 25 is 5. Root 2 is not, can't be simplified, so this is 5 root 2 plus or minus. We're doing this without a calculator, hopefully everybody knows. We got 3 bags of this. You can unload the bags, or you can get rid of the 3. It's the last thing being done to x, so it's the first thing we want to get rid of. Up to you. Either unload the bags or get rid. I'm going to go ahead and just get rid of it. I'm going to divide both sides by 3 because I can see that 21 divided by 3 is 7, so it's like an easy thing to do. Unload the bags. First, could have made it a little bit more complicated, but you'll end up in the same place. Now, how do I get rid of a 2/3 power? With a reciprocal power, like a 1/2 to a square, a 1/3 to a cube, a 3/2 to a 2/3. It's all the same. Now, how do I figure out what 9 to the 3/2 is? I don't have a calculator. Well, same idea behind the power to a power. This is x squared 3 times. X squared, x is 6. You can multiply the 2 and 3. Okay. I can split this up to kind of undo the multiplication so that it's easier to do. I have the square root of 9. I can do that. 3 cubed. I can do that. 27. So I get 27. Easily done. Just by splitting up the power, the fractional power, into the bottom part and the top part. It's like I'm square rooting, then I'm cubing. You do that. One thing you have to note is that you are using a square root to solve the equation. This 1/2 is like using a square root. It's telling us that the original value could have been positive or negative because that value is taken to the 2/3, which means it's being squared and cube rooted, which means it could have been positive or negative because the signs would have worked out. If it was a negative, you square it, it becomes a positive. All that to say, this could be a positive or negative answer. Okay? If you're using a square root of a 1/2 power to solve an equation, positive or negative. All right. X, Y's. Inputs, overall outputs. For what input will my output be 18? Okay? Some of you like to replace this with y. That's fine. You do that, and then you have the equation, 18 equals 24x to the negative first. That's fine. It's all the same. Just different ways to think about things. Maybe we understand that this is x to the positive first. Maybe we multiply by x. I'm going to flip both sides. This is another way to do it. Instead of multiplying it by dividing, You can take the reciprocal of both sides. As long as your equation stays balanced and you're doing the same thing to both sides of the equation, you're good. This is me flipping both sides. Okay, what's being done to x dividing by 24? I'm going to multiply. So I get 24/18. Divide the top and bottom by, 6? And I get 4/3. Okay, so that's flipping. You could have also multiplied by x, then divide by 18, and you had an x on the right side. Totally fine. When x is -2, so this is 24 times -2 to the negative first. Well, that's the same as 24 over -2, which is -12. Why does h of x have no x or y intercept? Good question. Well, h of 0, when my input is 0, this would be my y-intercept. So let's examine the y-intercept. What happens if I have 24 times 0 to the negative first? Well, because you are not allowed to divide by 0. How do you remember this? Like, I always go back to 8 divided by 2. What is 8 divided by 2? 4. Why? Because 2 times 4 is 8, okay? That's one way to remember, okay? So 2 times 4 is 8. Well, what's 8 divided by 0? What times 0 is 8? Can't be done. Does not exist. It's undefined. There's no number because 0 times anything is 0. It's like, imagine having 0 bags of something. Well, can I have nothing? If I have 0 bags of something, I don't have anything. You don't have anything in your hands. So you're not allowed to divide by 0. That's my long-winded way of saying you're not allowed to divide by 0. So undefined. So that's one way. The other thing is, what if h of x equals 0? So this is when my output is 0. When your output is 0, that's when you have input value, your x value, that produces a y value of 0. So let's try to solve this equation. 0 equals 24, x to the negative first. Well, 24 divided by what gives me 0? Can't be done. It's like multiply both sides by x, and it's like x times 0 is 0. It's another thing that can't be done. So it's like you cannot divide by 0. It's probably the easiest way to answer that question. All right, a couple more. Very similar to the first ones. So let's do it. Here we have a x that's being multiplied by 3, then added 1, then square rooted. So to undo what's being done, I'm going to get rid of the square root first. The square root is a 1/2 power. Squaring. We'll undo that. We can only have positives in here, so we don't worry about positive or negatives because you can only square root a positive value. We'll get more into that, why there's no plus or minuses here. You don't have to worry about it. Get rid of the 1, that's the next thing bothering, and the first thing, which is the last thing we'll take care of, is dividing by 3. Divide the top and bottom by 3, we get 33. Boom. Let's get rid of the 4 first, and then the 2, and then we'll talk about it. $27. All right. If you treated this as like x is being cubed, then square rooted, and you want to get rid of the square root first, and you don't have a calculator, it's very hard to do because you have to take 27 and multiply it by itself. And then you're going to have to cube root that number, and you don't know what that is. What I like to say is don't forget, a square root is a 1/2 power. Okay? Square root is a 1/2 power. we know power to power rules where, the cube to the 1/2 can be multiplied. If you're multiplying fractions together, you're just like multiplying the amounts and the pieces. So like 3 times 1/2 multiply across, you get 3/2. This will be easier to work with because watch. It is easier to deal with 27 to the 2/3 than squaring 27, then cube rooting 27. Because I would rather cube root 27, take care of that first, then square it. The cubed root of 27 is 3, because 3 cubed is 27. Okay? So 3, and then 3 squared is 9. Our answer is 9. We're not square rooting. We are cube rooting, and we're squaring. I don't want a plus or minus here. Okay? Same thing here. It's probably easier, and maybe for this one, for the start, we're going to put a 2/3 here. It's probably easier to just start right there. Why do I know it's a 2/3? Because this is x squared cube rooted. A cube root is a 1/3 power. A square root is a 1/2 power. This is things that we learned in Algebra 2, and we're throwing it at you all at once because it's review. These are all the same types of questions because we're talking about isolate. It's like x to a power. We can isolate x. So we're just solving different types of equations, which is nice. Undo what's being done. Get rid of that -2, which happens at the end. Next thing that we need to undo is the multiplying by 3. We will give you nice numbers with these fractional powers. We don't want to complicate the arithmetic. It's more of like the process and understanding and the algebra behind stuff. Now here, I would rather square root 4 than cube. That's easier for me to do and think of. But since I'm using a square root to solve an equation, I have a plus or minus. So this is 2. 2 cubed is 8. Plus or minus. Okay? Flip both sides or multiply by the cubed root divided by the 54. Divide the top and bottom by 2. I feel like we did this. Yeah. Oh, that's a little bit not nice. I feel like we made a mistake here. I think it was supposed to be 54 over. No. This is gonna be a huge number. I'm not gonna do it. Unless I made a mistake here, but I don't think I did. No. Whatever 27 to the 3rd power is, that's what it is. Yeah, I'm not. I was gonna pull up a calculator, but whatever. All right, cool. Other types of questions. We got some sort of equation, but we don't know what k is. It's a constant, some value. If we see f is using x's, okay. F of 12 is supposed to output 4. Okay, so if instead of using x, I use 12. Instead of using x, I use 12. Still don't know what k is. Not going to plug in 12 for k. It's not what's being used in my function. But we are told that when I use 12, I should get an output of 4. Oh, we can find what k is, and then we'll have an equation without k. You can multiply across or divide the top and bottom of this, like 5 times 12 over 6 by 2, by 6. Like 12 can be divided by 6 is 2. Then times 5 is 10. I mean, let's talk about the different ways to do that. You could write this as 5 times 12 over 6. And instead of multiplying, you'd be like, oh, divide the top and bottom by 6. That's a thing. You can see how that works out for... That works out for if you multiplied 5 and 12 and got 70. 70 divided by 6. That's not right. 60. 60 divided by 6. It's 10. Whatever. Just get that it's 10. All right, we get k is negative 6. All right, now that we know what k is, we have our f of x without k. And now we can find what f of negative 6 is. It's the whole times 6 divided by 6. 6 divided by 6 is just 1. I got the negative, so I get negative 1. There you go. Same thing here. Make it a video.
Oh, sorry.
All good. Thank you. We got to get his calculators. It's Mr. Huffaker, one of our other AP pre-calculus teachers, popping in.
Hello.
I'm over-explaining myself here, Mr. Huffaker. Some of the kids might be intimidated by my reasoning. I like to call this the amount of bags of something. So it's like you got 3 bags of x plus 4. Empty your 3 bags. Well, now we have 3 x's and we have 12. You know what I mean? That's distribution in Mr. Messner's Algebra 2 terms.
Right, good luck, pre-calculus students.
I like to try to not do the just do this. That's the thing.
Or doesn't last.
The just do this don't last. Mr. Huffaker is on board. We don't like to do just do this. We like to understand. All right. Here, if I use 2 for x, I should get 4. I am going to undo my bags here, distribute. I get 3 halves plus 3/4 of a k plus 1 has to be 4. If I have 1.5 and 2, like 3 halves and 2 halves, I have 5 halves. These are 8 halves. Just common denominators. Subtract 5 halves, I get 3 halves. Get rid of 3/4 by either dividing by 3/4. If you divide by 3/4, understand that's the same as multiplying by 4/3. Get k is 4 divided by 2 is 2. 3 divided by 3 is 1. K is just 2. It's nice. So, using that information, we do now know what f of x is. What's f of negative 2? Oh, well, that's really nice. It's just what k is. Or it's just this 1. It's not what k is. Cool. Let's make sure that works. If I plug in 2, 4, I get 4. 3/4 times 4 is 3. Plus 1 is 4. Negative 2 plus 2 is 0. Okay. A couple other ones, and then we're done. Again, if you did this and watched this entire video, it took you really long. It took you really long. You're using this video to check. All right, a rectangle has a length x plus 3 squared and a width 5. I don't know which one should be labeled as what. I'm not a geometry teacher. It's the one class I haven't taught in this high school. I've taught a stats class. I've taught all of the algebras, but I've not taught geometry. The perimeter is 50. All right, well, I have 2 of these x plus 3 squareds. I have 2 of these 5s that I'd have to add. You have to add all of these sides together for the perimeter. We know that. Okay? So when we add them all together, I'll double the width and double the length. And now I can solve. Let's undo what's being done. I'm going to subtract 10 divided by 2. Yo, we're an AP pre-cal. You don't have to show all the steps. We know you can do math. Like, we're getting the right answers. Get the right answers. Subtract 10 is 40. Divided by 2 is 20. Get the right answers. Square root, or 1/2 power. Root 20. 4 goes into it. Root 4, root 5, 2 root 5. Subtract the 3. Boom. This is what we would ask you to leave your answers as if you have a combination of a root, a rationalized radical that doesn't simplify to a whole number, and then a number. That's good. We'll see more of those next class when we're using the quadratic formula. We've all 2 classes from now. Next class, we're going to be reminding of how to factor. Same question. Double the length plus double the width will equal our perimeter. We could have done the area too, but this is good. Subtract the 8, divide by 2. I got 78 divided by 2. This one I am going to show because it's not as easy to do in my head. 72 divided by 2 is 36. All right, that's nice. Square root. Add 1. -5 and 7 are possible values for x. X could be both of this, the negative or the positive number, because you're going to subtract 1 and then square it. So it doesn't matter if it's positive or negative. Same here. Doesn't matter if it's a positive or negative. Yeah, that's it. That was the first homework. Hopefully it didn't take you as long as this video took. But you got to struggle. You have to do it. You have to redo the ones you didn't understand, didn't get. Don't think those types of problems are going to disappear. This class, just like my AP Calculus class, the homeworks are made after we made the quizzes. The quizzes are made after we make the test. We make the test first. We make sure you're going to see similar types of problems on the quizzes, and we make sure you're going to see similar types of problems on the homework. So since we're making everything, trust us. You got to know how to do everything on the homework, because those types of questions are going to be on the quiz, and those types of questions are going to be on the test. All right? Homework 1 video, Mr. Messner, out. See you Friday.